All right, welcome you guys. So let's go ahead and finish off our final exam review. So we'll be looking at problems 31 through 40 in this video. All right. So some important formulas for your cheat sheets for this one. There's two of them. The first one is going to be the formula for a circle, standard formula for a circle. So that's going to be x minus h squared plus y minus k squared equals r squared. And if you have it in this form, then the center of the circle is going to be at h comma k. So this is a big one that you'll want to have on your cheat sheet. But also you're going to need the formula for completing the square. Okay, so completing the square. I can't remember if we wrote it down earlier or not. So I'm just going to put it in here. So take half of b and square it. And that's going to be our other thing. All right. So on this particular problem, what we're going to do is we're going to try to make it look like that. That's our goal, right? This one right here. Okay, so let's get all the x's gathered closer together. So I'm going to put x squared and negative 10 or minus 10x closer together. And I'm going to leave a little space after them. And then I'm going to put all of my y terms close together and leave a space after that. So we just did some rearranging. And now we're going to go ahead and complete the square twice. The first time we're going to complete the square with the negative 10. So we're going to take half of b and then square it, where in this case, b is going to be negative 10. So half of negative 10, forgot my negative sign. Hold on. So half of negative 10 is going to be negative 5. And negative 5 times negative 5 is going to get us 25. So we're going to add a 25 to the left side of the equation. Whatever you do to one side, you're going to do it to the other side also. Now we're going to repeat that process, but with the y. So we're going to use the positive 10. So again, we're going to have to take half of b and square it. So we're going to take half of positive 10 and square it. So this time we get positive 5. 5 times 5 is. So we're going to add a 25 here. And we'll add a 25. All right. So these are actually pretty simple to factor. You're going to take this entire trinomial and you're going to write it as x minus 5 squared. You're basically just taking the number right before you squared it and you're going to insert it right there. So for the second trinomial, so for this trinomial right here, it's going to be a y plus 5 this time, because you can see that over here, it's a positive 5. Okay, so when we put that in, make sure you put a positive 5. Then if we do all of the math, the negative 46 plus 25 plus 25, that's going to be negative 46 plus 50, right? So that's going to be 4 when you combine everything over here on the right-hand side. So now we have this pretty much, in our standard form for a circle. So our center for our circle, now we're going to just change the signs on anything that's in parentheses. So this minus 5 is going to be a positive 5, and this positive 5 is going to be a negative 5. And remember, the right-hand side is actually r squared. So if r squared is 4, then we square root both sides to get that the radius is going to be 2. So we have everything that we need for the directions here. All right, so that's number 31. Let's take a look at number 32. Find the vertices of the ellipse. Okay, so to find the vertices of the ellipse, we're going to have to first notice that, or remind ourselves that the bigger number in the denominator is always your a squared. And the smaller number in the denominator is always your b squared. Okay. Now let's kind of think about our formulas from this section. I might even write them out just so you have them for your note card. Okay. So both of them have x minus h squared and y minus k squared. The only difference between two is the following. So if the a squared is under x versus if the a squared is under y. That's the only difference, okay? So if you have the first case where the a squared is under x, then in order to get to your vertices, you're just going to take your center, which by the way, our center is always h comma k. Doesn't matter which one of these formulas that we have, you guys. And you're going to take the x value, the h, and you are going to add and subtract a to that. Whereas if the bigger number is underneath y, then for your vertices, instead of doing it to the h, you're going to do it to the y value, the k. Okay? So if the bigger number is under x, add and subtract it to the x. If the bigger number is under y, add and subtract it to the y. It's that simple. And the center is still the same. H comma k. Okay. All right. So it's always the letter A for vertices. Okay. Different if it's foci, but vertices. Okay, so let's go ahead and start off by getting our center. So right here, if we change the signs on both of these, it's going to be -2, -4 as our center. Let's see here, -2, -4. Okay. So because the bigger number is underneath x, that means that we are going to add and subtract a to the x value, and we're going to leave the y value alone. This is what's going to give us our vertices. Okay. Okay, so let's get a. So if we square root both sides, we find out that a is 10. So we're going to take that 10, we're going to substitute it in right here. So -2 plus or minus 10, comma 4. All right, so let's see here. -2 plus 10, and then -2 minus 10. -2 plus 10 gets us 8, so 8 comma 4 is going to be one of them. And -2 take away 10 is -12. So these are going to be our vertices. So we made it longer than it needed to be because we just went over every possible case over here, wrote down all the formulas, right? Okay. But it'll be really fast. Just go, okay, the bigger number's under x. Okay, let me make sure that I do it to the x value. The bigger number had been under y, then we would have been doing it to the 4, the y value. It's that easy, okay? And we didn't even need the b squared, you guys. Turns out we only needed the a. So this could be a really quick problem as long as you remember those things. All right, let's take a look at 33. Find the asymptotes of the hyperbola. All right, so we have either a hyperbola where the x is first, and one case, or we have the hyperbola where y is first, the case that we're looking at, right? Oops, I'm sorry, I don't know why I put either, you guys. Where it is always first on the hyperbolas. Okay. Now, in the event that the x is first, then this is going to be the formulas for, sorry, it's hard to talk and write these formulas down at the same time. This is going to be your formulas for your asymptotes. So let me go ahead and label that. Put up here. In the event that the y is first, nothing much changes except for instead of b over a over b. You have these on your note card. You will be good to go on this problem. It won't be very tough. So let's go ahead and look. So we have y first. So that means that we are going to be using this formula, right? Okay, so in order to use that, we have to put the y parentheses first. That's going to be our y minus k. Okay. Plus or minus. And then we'll put the x parentheses second. Just leave them as they are. You don't have to change a thing. Okay. Just make sure you don't put squares on them, right? But now we have to get the a and the b. So remember that a squared is always the first number. It doesn't matter if it's bigger or smaller. It's always the first number, and b squared is always the second number with hyperbolas. You'll notice that here. So if you write these on your note card, you'll be good to go on that, okay? All right, so we'll square root, and we get that a is 20, and we'll square root, and we get that b is 15. So according to our formula, it's a on top of b. So let's go ahead and stack the a over the b, right? This is going to be our a over b. We'll have to reduce that. I can see that 5 goes into both. So this is going to be 4/3 that we're going to basically slide in right here. Okay. All right. So from there, let me check really quickly the answer key on this because I want to see how they wrote it. Okay, let's take a look at the answer key. Just to see how far we have to go, you guys. All right. I think this is problem 33. So let's see how far they went. 33. Wow, okay, that's enough right there. Okay, so they did write them out separately, but they didn't do any distributing. So they did the plus case. So y plus 1 equals 4/3 x minus 3. And then y plus 1 equals negative 4/3 x minus 3. And that's how they wrote it. Honestly, it'll probably be enough to just go to this point, and then you'll easily be able to tell from the multiple choice which one it is, you guys. So we don't have to get it into y equals mx plus b form. That's what I was checking for, okay? All right, so this looks not too bad if right, you have a really good note card where you've written these two things down, okay? So let's just kind of recap. Take the parentheses for the y, put it on the left side. Take the parentheses for the x, put it on the right. Make sure a squared is the first number, b squared is the second number. Square root those guys. And then go over here and see if you need to put b over a or a over b. Just depends on the original, right? And then make sure you reduce because they're not going to have 20/15ths there. So make sure you reduce it when you plug it in. Awesome. Not too bad of a problem. 34, graph the function. Okay, so a couple things that would be, there's probably 3 things that I'll probably use on this, okay? Number 1 is finding the zeros. And in order to find the zeros on this, we can see that we have 4 terms, right? 1, 2, 3, and 9 right and forth. We said usually in that case, you slice it down the middle and you use factoring by grouping. So I'm going to take out an x squared from these first 2 terms, and that'll leave me with x plus 2. And I can see that we need to change the signs on these, so I'm going to factor them. That way I can change all the signs. So x plus 2 is going to get factored out of both terms. So that'll just leave us with x squared minus 1. And then from there, if you want, it's up to you, but you can factor this difference of squares and make it x plus 1, x minus 1, or you can just set it equal to 0 as it was, okay? All right, so when we set each one of these equal to 0, we're going to get the opposite, right? We're going to get a negative 2. When we set x plus 1 equal to 0, we're going to get a negative 1. And then when we set x minus 1 equal to 0, we're going to get. All right, so it looks like negative 2, negative 1, 1. Now, another thing that's nice to know is that the last number is always your y-intercept. Remember how we find y-intercepts? We substitute zeros in for all the x's. Well, if I substitute zeros in for all these x's, then they'll all go away, just leaving me with the last number. So that's the reason why the last number is always your y-intercept. So we know that we go through negative 2. Okay. All right. So the end behavior is helpful, although I think we probably have it on this one without the end behavior, but we can go over that just because it's nice to review anyways, okay? So for the end behavior, we only need the leading term. So we only need the x, the 1x cubed, right? So remember we said the front tells us what the right is doing, the exponent tells us what the left is doing. Since this is a positive 1, we know that the right is going to go up. Since this is odd, we know the left does the opposite, odd opposite, okay? So the right is going to go up and the left is going to go down. So we can kind of make this happen now. Now, I don't know how high or low to go, but it's not going to matter, you guys. Okay, boom. Something like that. It's multiple choice, there'll only be one that's anywhere near that. So if you're like, man, I didn't know how high to go on this Mecklenburg, do I go higher? It's not going to matter. That's something that we'll tackle when we get into calculus and we find relative mins and x's. For now, just make sure that you have the correct in behavior and the correct zeros and you are good to go. Okay. Now remember, it is multiple choice. At any point, maybe you don't have to do all of these steps. Maybe there's only one graph that had these zeros, you know, hey, stop there. Maybe there's only one graph that had these zeros in this y-intercept, okay? So I'm just doing it worst case scenario in case there's a couple of graphs that actually do have the same zeros. All right, you guys, that's number 34. 35, graphing the inequalities. Okay, so I'm going to go ahead and do this first one in black. And then I will do the second one in blue, so you just know which one's associated with which one. So we can tell, because this is an x squared, that it is a parabola. And we know that this shifts the parabola up 8. And this is what makes the parabola face down, right? Okay. So I'm going to have a parabola that goes up 8 and it faces downward, okay? And I'm not going to be super accurate on it, you guys. I could be, but honestly, I don't think it's needed on this, okay? Now I made it solid. Why did I make it solid? I made it solid because of the or equal to. That's what's going to make it solid. Now this is a less than sign, right? So that means that we are going to shade below. So if I could come in here and shade, let me do it with like, we'll do orange. I want to shade this portion. It's going to keep going, obviously, but out of space. Okay. Let's go ahead and look at this other equation that we have. Now I'm going to get it into y equals mx plus b. So I'm going to move the x over to the other side, making it a negative x. And then I'm going to divide by a -1. And anytime you divide by a negative, the sign has to flip. Big deal. Okay, huge deal. Okay, a negative divided by a negative equals a positive, and a positive divided by a negative equals a negative. So this is a line, it's not a parabola like the last one, okay? We know that this last number is our y-intercept. So I'm going to put my first dot at -4, okay? Let me kind of shrink this down a little bit, you guys, just so I can make extra long y-axis here, okay? All right, so y-axis wasn't long enough. I'm going to go a little bit longer. We'll call this -3 and go negative. So I'm going to put a dot there. And oops, I want to do it in blue. There we go. Now, the number in front of x, that's going to be your slope, right? So we know that our slope is 1/1. So up or down, well, it's positive, so we're going to go up. Left or right, well, it's positive, so we're going to go right. So I'm going to go up 1, right 1, up 1, right 1, etc. Blah, blah, blah. Now, this time we don't have the or equal to, it's just a less than. So that means that I need to make this dashed when I draw it. So I'm not going to make a solid line. And since it's a less than, we're going to be shading below it, right? No, I'm sorry, it's a greater than. Whoa, I looked at the wrong spot, you guys. Hold up. I forgot we flipped it, right? So it's actually a greater than. So greater than means shade above it. Above. Okay, so I would shade this way. Now, what do I care about? I care about where I've been double shaded. So like the actual answer on this problem, I'm just going to make these guys intersect so you can see the area. The actual answer on this problem is just going to be shaded in here. This is only thing you're going to see on the multiple choice, right? you will not see that yellow or the orange, okay? So wherever you've been double shaded, that's the answer. Okay, so one thing, let me talk about when I'm grading this, what students miss, okay? They try to not pick up a pencil. They try to do this with just like looking at these inequalities. And so they'll say, okay, I know this one's got to be solid. I know this one's got to be dashed. And they'll go, these are both less than, so they both need to be shaded below. And then they miss the problem. You really do have to get into the dirty details here of solving for y, because sometimes the sign flips on you. Okay. So like it may appear like it's a less than, but when you go through doing the steps and you see that you've divided by a negative right here, well, that changed our less than into a greater than. And so we actually shaded above. So I see students missing this one a lot because they just don't want to get down into the solving. They kind of just want to be able to look at it and tell. But you really do want to make sure you solve for it. Or maybe if you could see it without, which I don't recommend, but if there's a negative in front of the y, this sign is going to flip. Okay, so that's another way that you can look at it. You just got to keep track of that. There's a negative in front. I'm going to be dividing by a negative at some point. This sign is going to flip on me. Okay, I highly recommend just going through and doing it yourself. When students try to just look at the multiple choice and guess from it, that's when they usually miss it. Okay. All right, so some things to have on your notes for this. You already wrote down y equals mx plus b earlier. There was a slope-intercept problem earlier. But maybe if you don't know when your line is solid or dashed, or when to shade above or below, I would probably put those things on like art, okay? So basically it boils down to either one of these, right? It's going to be a solid line. These without it will be a dashed line. Greater than or greater than or equal to or greater than means you're going to be shading above. And less than or equal to or less than means you're going to be shading below. This might be something you want to have in the cheat sheet if you don't already have that memorized. All right, let's take a look at number 36. I feel like the end of the test is actually the easiest part of the test. So make sure you make it there and that you don't run out of time. Go and get those easy points first. They want us to find a sub 12, the 12th term. So we're just going to be substituting 12 in for all of the n's in this problem. And that's it. It's that easy. So I'm going to go ahead and write it with 12s everywhere where I see an n. And then you can just have your calculator do all of this if you don't want to do it. Okay. Well, you can type it in as is, right? 5 parentheses 12 squared, and then parentheses 16 12 minus 1. Put it all in like it looks. Boom. Oh, that's a huge number, huh? Copy it right, you guys? Yeah. Okay. That's totally fine. I recommend doing that on a test because if you're trying to do it by hand, don't trust yourself, right? 12 times 12 is 144. 16 times 12. See, I would even need my calculator for this. That's why I would probably just put the whole thing in. 192. 192 take away 100 is just 92. And 5 times 144. 5 times 144. 720. And then I just need to do 720 times 92, right? Okay, it genuinely was. Okay, so when I'm working it out, I get the same answer as the calculator. So I'm pretty convinced. So you can just plug it in. This just boils down to putting a 12 in for all the n's. You guys got this. 3 points right there. You're welcome. All right, number 37. Find the first 4 terms of the recursively defined sequence. Okay, so we need to find the first, the second term, third term. Well, they already gave us the first term. Cool. Take it. Now, the way that it works, a recursive formula, is that you're going to be plugging in the first term right there to find the second term. So we're going to plug in a -2 plus 7. We're getting 5. Now, for the next term, I'm going to plug the 5 in there, right? So we got 5 plus 7, which is 12. Then to find the next term, we're going to plug the 12 in. 12 plus 7 is 19. So to find any term, you're going to use the term before it. You can see that here in the notation. A sub n and A sub n plus 1. Well, that's one term and the term right after it. Let's just kind of make sure that makes sense. If this is A sub n, then A sub n plus 1 would be the next one, and A sub n plus 2 would be the next one, etc. If I backed it up, A sub n minus 1 would be the one before it, and A sub n minus 2, etc. So when you see A sub n and A sub n plus 1, you know it's a term and the term after it. Okay. So right here, anytime, right here, you want to start by plugging in the first term right there, doing the math, that'll get you the second term. Then use that term to find the third, use the third term to find the fourth. Okay. Easy stuff once you understand how it works. We need that -2 to get the ball rolling. But after that, you just use the answer you got from that every time, right? So plug a 5 in for the next one, plug the 12 in, okay? All right, easy math too. I can add 7. Give me more problems like that. All right, number 38, find the indicated term. We need the 12th term. Well, it's arithmetic. So make sure that you have on your note card the formula for the nth term, I should put this, sorry, the nth term of an arithmetic sequence. So to find any term, it's the first term plus n minus 1 times. So if this is on your note card, you're going to do a great job on this. So let's go ahead and find the 12th term. So let's plug a 12 in. Our first term, a sub 1, well, that's 1. And this will be 12 minus 1. Now, the common difference is what you're adding every time. So it looks like we added 5 to get from 1 to 6. And we added 5 to get from 6 to 11. So it looks like our D, our common difference, is going to be 5. So I'm going to put that 5 right here. All right, so if we do the math, 1 plus 12 minus 1 is 11. Whoa, I'm already writing 55, and it should be just a 5. All right, now remember the order of operations. I got to multiply first before I do addition. So 5 times 11 is 55, or 11 times 5. And now we end up getting 56. Now, it wouldn't be too hard, you guys, also, if like, let's say you, worst case scenario, you didn't write this formula on your note card, right? And we're looking for 12 terms, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have a calculator, you know, you already have up to the third term. We're just adding 5 every time. Plus 5, plus 5, plus 5, plus 5, plus 5. I'm just gonna keep it. Boom, right? That is, you know, hopefully they don't ask for like the 37th term, right? But it's just the 12th, you know, heck, I can add 5 till I get to the 12th term, right? So that's your backup plan. It's uglier, so I call it plan B, right? Try to have your plan A here. It's a little slicker, and heaven forbid they give you a bigger number than 12, then you'll really want this formula so you're not, you know, continually adding the common difference every time. All right, so that's number 38, 39. Find the indicated term. Now, we are not adding anymore. Like if I did, that's plus 4, but that would be plus 8. So this is not arithmetic. So this one is actually geometric. What we're doing each time is we're multiplying by 2, etc. So now we need the formula for the nth term of a geometric sequence, right? Okay, the nth term of a geometric sequence. So that is a sub n equals a1 r to the n minus 1. Okay. So we want to find the 9th term, so let's substitute in a 9. The first term, the a sub 1, well, that's going to be 4 in our problem. That's our first term. The common ratio, well, that's what we were multiplying by every time. So our common ratio is going to be 2. And we already said n is 9. So we have to put in 4 times 2 to the 9 minus 1 to the 8. And I would just put it in my calculator because these get pretty big, you guys. Oh, that wasn't that big. I probably could have done that one by hand, but there we go. 1024. So a good note card, gonna make all the difference. Again, this would not be hard to go 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my 9th term. We already know the first 3 of them, and all we're doing is doubling, multiplying by 2 every time. Heck, it might be faster to go this way, you guys. Uh-oh, now I'm hitting might be a little too hard for me. Let's see, 256 times 2, 512. Yeah, and if I double 512, that is 1024. Oh, it wasn't that bad. So if you don't have it on your note card, no problem. You can always just do it by hand. Last problem, you guys. So we have to write the formula. So we already wrote them down on these last 2 problems. We just have to decide, is this arithmetic or is this geometric? So to get from the first term to the second term, I'm adding 8. It looks like I added 8 here as well and here as well. Okay, because I'm adding, we know that this is an arithmetic, right? Arithmetic sequence. I wasn't multiplying with, so it's arithmetic sequence. So we are going to be using this formula we wrote down 2 problems ago. That's an n. Sorry, guys. N minus 1 times d, right? All right, so to find any term, you just need the first term, which is 2, plus n minus 1 times, well, our d in this case, we decided is going to be 8. Now, they do clean it up, I believe, so I'm going to clean it up. We're going to go ahead and distribute that 8 in, giving us 8n minus 8. And then it's going to be 8n, and when we could do 2 minus 8, we get minus 6. So be prepared for them to possibly clean that up, make that a little bit neater. Let me just double check to make sure I'm not steering you guys wrong on this. This is this the last problem? It is, okay. Yeah, so there it is, 8n minus 6. Oh, that's so bizarre that they didn't put an a sub n on that one. Huh, interesting. All right, so that is it, you guys. Wow. Okay, so it's going to look just like this, right? I'm just going to be changing the numbers. And so I can guarantee you that you don't need to write down any formulas except for ones that we've used here in these videos, okay? You don't want to clutter your note card with too much stuff, just the right amount of stuff, right? So I don't recommend going through your notes and just writing everything down. I recommend just doing these videos, and anything we did in these videos, make sure it's on there. All right, feel free to email me if you have any questions. Good luck, you guys. Thanks for joining me.